Hello everyone, thanks for tuning in. I'm sorry I couldn't be here yesterday. I had a family emergency, so again, apologies. Today we're going to be kind of going through a lesson here. I want to go through two problems today that kind of give you kind of a taste for what you need to do in that homework assignment that I assigned yesterday. So you had to find, you had to be able to find the center and the major and minor axis for an ellipse. So that's what we're going to look at today. I'm even going to look at one extra piece that we're going to look at for Friday's assignment. This assignment that I assigned yesterday is due Friday, so keep that in mind. I think I have it set for due for Friday. So yeah, let's kind of work way in. Remember, ellipses are where it's kind of like a circle, but it's been elongated, right? So wherever your center's at, let's say my center on my particular picture is right here. That's my center, and we're going to go, either direction. That's where the major minor axis comes in. Whatever way is the longer distance is your major axis. Let's say in my particular case, the major axis is going 1, 2, 3, 4, 5 up, and 1, 2, 3, 4, 5 down. So the minor axis going right and left would be smaller than 5 because I counted 5 up and down. So maybe we go 2 right and left. And so this is my ellipse, right? So the major axis is going up and down, the minor axis is going left and right. So the new part today, what we're talking about, not just, which direction do we go and how far do you go. That's something we'll look at in the formula here. It's the main focus of today that we're going to look at, and tomorrow in the notes, will be where the focal points are, where those gravitational bodies are, not just the center of the graph. That's kind of nice, but when we do an ellipse, that's in a planetary system, right, a solar system. The gravitational bodies that are sitting there are on the focal points. So the focal points are always along wherever the major axis is stretched, wherever the longer distance is. In my case, on this particular picture, the longer distance is going up and down. So the focal points would be somewhere going up and down. Now I'm just kind of picking them right now. I don't have a set number. I can figure that out here in a second. That's going to be a part of the formula today. We have a new part of it. But the focal points, focus 1 and focus 2, whatever one you want to call which, they're going up and down from the center. And they're going to go the same distance from the center. So mine are not perfectly drawn correct. They're not drawn very well, but you get the idea. That's what we're going to look at today. Where are those two new points? This is the new stuff today. So I'm going to do a little review, show you kind of what you're doing in your homework, and then I'll kind of apply this new piece. This is the one extra piece I want to add in today. I was going to do it yesterday, but apologies I couldn't be here. So yeah, so let's jump right in. So the problem I want to start with is this one. You probably recognize it. It was the Google question of the day yesterday, so I want you to try one of these out. So what you have to do is you had to find the center, find the the major and minor axes, and figure out where those coordinates are. This is what we had to do on Tuesday, right? So okay, so here's what we're doing. We're going to be grouping things up. So I'm going to move some stuff around. I'm going to move the x's next to each other. I'm going to move the y's next to each other. And then I'm going to move any numbers to the other side. So in that case, I'm moving the 10 across and it becomes a 30 when I move that over. So that was kind of the basic rule that we've done. This one was kind of unique. We had a number on the other side. We had a 20 on the other side. Usually we always have a 0, but this one had a 20. So I kind of grouped them. I'm going to now kind of color code so you can hopefully see this. I'll put green and I'll put maybe that purple color. I kind of like that color. Alright, we're going to group them like this. So let's do the first ones in green. So in green I have to factor out the 3. So, because again, you can't have a leading coefficient out front. So I'm going to factor that out. So if I factor that out, that's x squared plus 2x. Right? Because I'm pulling that number out. Okay, so now for the y's now, they have a 2 leading coefficient. So I'm going to factor the 2 out. Right, so factoring out that 2, so we have what, y squared plus 4y, because I factored out the number in front of the y there. And then on the other side of the equal sign, we have the 30 still. That hasn't really moved. I haven't really touched that yet. Okay, hopefully that made sense. Hopefully it's all the same material to you. It doesn't seem like anything different here. So I've kind of factored out my numbers. Now what we're going to do is we're going to take half the middle squared. So the middle term on each of these. So this item here is a 2. A half of it is 1, and I square it, right? Half the middle squared is 1 still. 1 squared is 1. So I'm going to put that here. I'm going to take it times the number out front, since there is a number sitting there, and that's what I'm adding to the other side. So I'm technically adding a 3 across. again, it's half the middle squared. That's where that number is coming from. Times the number out front, add it to the other side. And then same thing with the 4. This is the middle term over here. Half of it's 2, square it's 4. You're going to take it times the number out front, which is a 2, and technically that's an 8 that I'm adding to the other side. Again, it's half the middle squared times the number out front. That's where I'm getting this 3 and 8 from. Again, if you need to pause, Mrs. Scott can pause it for you, and then you guys can discuss where these numbers are coming from. Somebody in the class probably can understand what I'm writing there. Now, I'm going to factor these up, so I'm going to keep these kind of color-coded. So factoring the part in green, it's always half the middle, so it's x plus 1 squared. For the part in pink there, half the middle is y plus 2 squared. It's half the middle. And then on the other side, kind of adding those numbers up, we have 33 plus 8, what is that, 41 on the other side? So that is kind of a goofy number. 3 plus 30 plus 8. Yeah, kind of a goofy number. And so now we're going to divide both sides by 41. So we'll get a decimal here, it's fine. You can have a decimal, it's totally fine. Most of the problems are decimals, so don't feel like you did anything wrong. Yeah, kind of looking back at the problems, it doesn't look like it appeared I have factored anything wrong. So, alright. But yeah, let's keep going here. So we're going to divide everything by a 41. Because again, I need to get a 1 on the other side. So divided by 41, divided by 41, divided by 41. Now, this is the goofy part. So in this first x location, notice the 3 on the top. The 3 and the 41, we have to simplify those. I don't want to have a number both top and bottom, so I'm going to divide both numbers by 3. So 3 divided by 3 on the top is a 1, so I just kind of get rid of it. But 41 on the bottom divided by 3, I get 13.6. So kind of roughly, ballparking it. Then for the next one, 41 divided by 2, because I have to get rid of the 2 off the bottom. So 20.5. And again, there's decimals here, so I'm just kind of rounding it. That one was kind of a nice number, but that 41 divided by 3 was not. And 41 divided by 41 on the other side is a 1. Alright, so this is the equation for my ellipse. How I know it's an ellipse, they had different numbers out front. Right, that kind of gives it away that it's an ellipse as opposed to a circle. That's what we talked about yesterday. So we're going to go graph this thing. I'm going to talk you through the points where we find the center, we find the major and minor axis where those coordinates are. Again, they're going to be decimals, so don't be worried about that. And then we're going to look at the new part today, which is the foci, or the focus locations where the gravitational body would sit. So I'm going to transfer this over to my next picture. So again, if you need to hit pause or rewind, you can do that. You have the video there, you can have free will for that. So let me write this down. I'll go back and check. I think these are what we had. 20.5 and a 1. Let me just double check that I wrote this correctly. Y plus 2, 20.5, yep, and a 1 and 13.6. Yes, okay. Sorry, going back and forth, just trying to check my work. Okay, so let's draw the center here. Let's do that first. That's always the same part. The center of mine, this is part that I think most people kind of had down from the first day of doing this. It's the opposite with the x, the opposite with the y. So that's the numbers in the parentheses. So, and so it's the opposite of those numbers. So -1, -2. So here's where my center is, if my iPad allows me to write it. There it is. Okay, there's my center. Oh, sorry, wrong spot. No, not. There we go. Okay, it doesn't like me to draw in that location. Okay, so -1, -2 down. There's my center. Now, how to find the major and minor axes, going up, down, right, and left from there. That's where I use these numbers right here. I'm going to use these numbers and take the square roots of them and go up and down, right and left. So how I know which way to go. X's. So if I look below the X, that's the part I have in blue here, right? The X's. X's only go right and left. That's how X numbers work, right? They travel along the X-axis. So if I take the square root of 13.6, whatever that number is, ballparking it was 13.666, right? So if I take the square root of 13.6, repeating, this number turns out to be 3.68. Ballparking it. So that's how far right and left I'm going from the center. So 3.6 this way. So 1, 2, 3.6. And 1, 2, 3.6. So there's my coordinates. And again, how do I get those coordinates? You are taking the center and adding and subtracting 3.68 to the right and left motion. That's how I'm getting those numbers. I'm adding the 3.68 that we just found to the x number. That's how I get the x coordinates. So again, I'm going to end up about 2.5-ish and negative, what, 4.5-ish? Kind of in that ballpark? 4.68, roughly. And then going up and down for the major axis, and again, how I know it's the major axis, it is a larger number. The 20.5 is a bigger number than 13.6. So I know that the major axis is going up and down. Again, it's the y number is the top, so that's how I know it's going up and down. So we're going to do the square root of 20.5. I'll ballparking in. Again, these are approximations. So square root of 20.5. That's what, 4.52? That makes sense. It's almost close to 25. The square root of 25 is 5, so it's close. And so I'm going up 4.5 and down 4.5. So 1, 2, 3, 4.5. And 1, 2, 3, 4.5. And there's my coordinates. Again, how I'm getting to those coordinates, I'm taking this center and I'm adding and subtracting 4.52 to it. That's why I'll end up at negative 6.52, as you can see, and I ended up at about 2.52 going up in the air. Again, it's adding it to those coordinates for the center. And then drawing this thing out, kind of looking at where this thing is going. This is kind of my main drawing here. There you go, there's my ellipse. Now the major axis is actually going up and down, so because that's the further distance, it's the square root of 20.5. Now, the one new piece I want to talk about today was how to find where the foci are located. This is just a new piece. I'm just going to throw this in here just so you can see it. You did not have to do this in the homework or anything like that. That might be the new assignment we get on Friday. Might be like 1 or 2 of them. You have to try it. I'm not going to assign a lot of these. But the foci formula, or the focus, where the book refers to them as foci, right? Plural. The formula is this. It's a squared minus b squared. I know it looks like the Pythagorean theorem. It's really not. So a squared and b squared. Now, on this particular case, a squared and b squared are your major and minor axis numbers. It's actually these numbers. So I'm going to erase some of these lines up here. It's actually the original numbers on your picture up here. So it is these numbers. That's your a and b. That's your a squared and b squared number. Whatever number is bigger is your a squared number. So in my case, the 20.5 is the a squared number. And your minor axis is the b squared number. That's the 13.6. And this will equal your c squared. So whatever this number is, if I take the square root of it, because that's how I get rid of the little power of 2, you take the square root of whatever the difference between 20.5 and 13.6 is. So if I subtract those, what is that? The difference is about 6.9, roughly. 6.9 difference. So we'll have to take the square root of that number, and that's where the foci are going to be located. So the square root of that number, it's not a very big number, 6.9. 2.6, yeah, 2.6. So roughly 2.63-ish if I rounded it. And this is going along the major axis. So you have to kind of look at your picture and go, okay, I can see that it's been stretched kind of taller going up and down. So that's where the foci are going to be located, from the center. So they're going to be 2.6 away. So 2.6 away and 2.6 away. And here's focus 1 and 2 in no particular order from the center. Again, on a planetary system, a solar system, that's where the sun or gravitational body would sit. Maybe it's a star, maybe it's a black hole, maybe it's some other, other gravitational force of some type of planet, maybe. But yeah, so there you go. Okay, hopefully if there's anything that got lost in translation there, you can have Miss kind of rewind it back for you, or maybe somebody in class can take over and kind of walk it up to the board and kind of walk you through what we talked about here. Again, you can hit pause at your leisure. So I want to jump to the last problem here today. Last problem. Okay, same exact thing. I want to talk about this one. This is one I hinted at. This is the problem I was going to do yesterday in class, because I promised you I'd do a problem where if you could tell if it was a circle or not. And this is a circle. I'm kind of giving you that little hint right off the bat. This is going to end up being a circle. Now again, what gives it away is because if you look at the x squared and y squared term, they have the same leading number up front. On ellipses, it would be different numbers. So if you look at the last example I did, there was a 2 and a 3. They had different numbers there. This is going to be the same number, but we're going to do it the exact same way. And so I just want you to see the differences here. All right, so yeah, so you'll kind of see why this ends up being a circle. So grouping the x's together, here we go. This is good practice just because it looks just like your homework you're doing now. Moving that 6 across to get a 6 on the other side. Factoring out the number out front, the leading coefficient, x squared plus 5x. So we get a weird number. Factoring out a 2 here, I get y squared minus 7. So we're going to get some decimals. It's fine. Alright, so now we have to do half the middle squared. So half the middle, so 5, if I cut that in half, it's 2.5, and we're going to square it. So that's half the middle of 5 is 2.5. Square it is 6.25. That's half the middle squared. Again, this is the middle number. In fact, I'm going to change that color. Let's get away from this purple color. We have too much purple here. Let's go to green. Alright, 6.25. That's half the middle squared. We have to take that number times the number out front. So 6.25 times 2 is what? 12.5? And that's what I'm going to add to the other side. Half the middle squared. And then doing the same thing over here. The middle term is, it's negative 3.5. That's half of 7 is negative 3.5. We square it. We get a 12.25. That's half the middle squared. We have to take that number times the number out front, which is 24.5. And that's what I'm adding to the other side. Again, not pretty numbers, I know, but that was half the middle squared, and you always have to multiply by the number out front. So if I factor, here's what we have. We have 2, half the middle, so plus 2.5 squared. And then 2y, and half the middle is 3.5. If it lets me write the decimal, it does not want me to write that decimal right there. Come on, iPad. Why won't it let me write that decimal? It will let me write it above. That's a decimal. Sorry, my iPad just does not want me to write that in that location. 6 plus 12.5 plus the 24.5, and we get 43. Again, a goofy number. Shouldn't make it problems anymore. All right. Dividing everything by a 43 and kind of simplifying this problem out. So divide everything by a 43, divide by 43, divide by 43. Again, I said it was a circle, but I want you to see that you can do this just like an ellipse, and you'll see what will happen here. So we'll get a 1 on that side. Dividing these bottom numbers by 2, because I have to get rid of those 2's on the tops. So 43 divided by 2, I get 21.5, because I just need to get rid of that top number. And same thing here, I'll get a 21.5. And this kind of gives it away that it's a circle. It's a circle because the bottom numbers ended up being the same exact digit. On ellipse, these would be different numbers on the bottom. So you could tell which one is the major axis, because whatever the larger number is, that's the major way it's been stretched. These are the same number, so it is a circle. Again, kind of weird, goofy numbers here, but I'm going to go draw this, so if you need to hit pause and kind of go back through that, you can. But I'm going to flip to the next slide. I'm going to rewrite this equation again, so I'm going to have to go backwards and forwards here. So 2.5, and that's squared, and then y minus 3.5 squared. There's a 1 on the other side, and what were these, 21.5s or something like that? Yeah. Okay, I think it was 2.5 and 3.5, right? Yeah. Okay, so let's talk about how to draw these circles. So center again is negative 2.5 and up 3.5. That's the center of my circle. Negative 2.5, up 3.5. So we're kind of in a weird middle area. Now, to figure out the major minor axis, they're both the same number. We have to just take the square root of whatever these bottoms are, because they're the same number, so we're actually going the same distance, right and left, up and down. So the square root of 21.5, this will tell me how far I'm stretching. right, left, up, and down, because they're the same digit. So the square root of those numbers, that was somebody asked me on email yesterday about, you have to take the square root of those? Yes. It's always wherever the bottom number is square root. This ends up being 4.63, and that's how far I'm going up and down, right and left, because these ended up being the same digit. So, sorry, my palm is really activating the screen today. Alright, so 4.6 up, so 1, 2, 3, 4.6-ish, 1, 2, 3, 4.6-ish, right? And then 1, 2, 3, 4.6-ish, and 1, 2, 3, 4.6-ish. Alright, so there you go, and there's my circle. Now, what happens here on a circle is that the ellipse, the focus is always stretched along the major axis, but on a circle there is no major axis. You're not stretched one way further. So if you actually did the same formula that I just showed you a little bit ago, right? This same formula for finding the foci, right? Well, my a squared and b squared number ended up being the same number. They both were 21.5s, right? That was your bottom numbers on both, both fractions, and this makes 0, so that means your distance to your focus is 0, because you take the square root of 0, which is 0, and so that's still the same number, and so the focus is right on the center. It didn't move right or left, up or down. It was directly on the center. That's how a circle works. So that's why when you look back at some of those original mathematicians, those philosophers like Galileo, they had an extreme understanding of mathematics. They could understand that the focus was at the center. That's where the gravitational force would be if you had a circular orbit. If it's elliptical in any way, the gravitational force moves. So that's why everything was circular to them. They thought it was easier. That's why for a circle we still say it's 360, because they believed it was 360 days. It's really wild, like the stuff that hasn't changed in a long time. But yeah, so just kind of cool concepts. I really like the astronomy part of this unit. It's something that interests me a lot. But yeah, I'm going to give you time where you can work on your homework today. Again, it was the assignment that I signed yesterday in class. Sorry I couldn't be there. So make sure you're working on it. I think it's due Friday for you guys. Take care of each other, stay healthy, and we'll hopefully see you tomorrow. So, bye guys.